every year, there's some type of anomaly in the tropical Pacific. And when that anomaly is less than half a degree, it's kind of a wash. We don't really call that either El Nino or La Nina, but if it starts to exceed a half degree on either side, then we would label that. And when it gets above one, we would probably call that a strong El Nino or a strong La Nina. And then when it gets above two, it's kind of in a category of its own.
Can you compare the numbers that you're seeing for the upcoming months to any past El Nino events?
That's why we think this is a really interesting forecast, is because we, in our system, got an anomaly of plus 2.4 degrees Celsius. So this is above two. This is definitely in this extraordinary category. And we've only seen 3 of those events in the past 50 years. We saw this happen in 1982, 83, and then again in 97, 98. And that was a major event that caused a lot of havoc worldwide. And then the last time we saw it was 2015, 2016. So we kind of have these 3 examples in the modern era when we've been measuring the ocean with satellites that we can compare this to.
Yeah, and you mentioned worldwide impacts, and I think for a lot of people, it's kind of hard to grasp that you're looking at this one area of the ocean in one particular ocean with temperatures that may not sound that extreme, but it's having worldwide impacts. So can you kind of take me through a few of these impacts, like say for the rest of hurricane season? Is there any impact that we can expect there, or perhaps for next hurricane season, Atlantic or Pacific?
I think generally when we have an El Nino, we have a warming in the Pacific. We also tend to get a warming in the subtropical Atlantic that goes along with that. And, warm water is what fuels hurricanes. So the fact that we're seeing, this gradual ramp up in Pacific temperatures, I think, although I haven't checked, we could be seeing the same sort of warming in the Atlantic where hurricanes form. And so I wouldn't be surprised if, we had some late season hurricanes this fall.
Okay, what about the upcoming atmospheric river season? Last year was kind of a doozy. What do you think for this year?
Yeah, it's a good question because, last year, as I said, we were in La Nina conditions, and yet we had this string of atmospheric rivers that hammered California. I think in general, a general rule of thumb is, weather events are going to just get supercharged when we have El Nino. So this warming the Pacific is going to pump tons of heat into the atmosphere. And that's going to kind of like when you throw a rock in a pond, it's going to have these ripple effects in the atmosphere. It's going to change the location of the jet stream. It's going to a warmer atmosphere then will hold more moisture. So the storms that do come through will tend to just precipitate more. They'll just be packing more of a punch. So I would think that atmospheric rivers will be kind of even more devastating than they would normally be with an El Nino kind of adding to the mix.
How long will this El Nino last?
Yeah, good question. So they tend to peak in winter. So, we look at this DJF index because that's kind of when it's reaching its peak, and then it should decay in the spring. And by, I would say, March or April, the tropical Pacific will be on a cooling tendency. And a lot of times when we see these super El Ninos, they're followed the following year by a La Nina. That's something that we've seen consistently. We definitely saw that in 1997, 98, and to some extent in 2015, 2016. But you kind of get this whiplash effect, right? First you have this heating and this discharge of heat, and then the following year, it tends to be much colder than normal. So that's what I'm expecting, is that if we do see the super El Nino, it's going to cool rapidly in the spring, and then the following year we could see a reversal.
Talk to me a little bit about the modeling and forecasting of these events. Is this a relatively new science, the ability to look ahead and see what kind of El Nino it's going to be?
Yeah, it is. Seasonal prediction has been around for a while, not as long as weather prediction. So, we grew up in an era when weather prediction was just commonplace. We see it on the TV growing up. But, back in the 50s, they were still, developing this science of being able to predict the weather. and we're kind of in that stage with seasonal prediction, right? So it requires big computer models running on supercomputers. It requires a lot of observational data, which we didn't have a lot of until satellites. And so, we're getting to the point where, we're testing, at least at NCAR, not only can we do seasonal prediction, but how far into the future can we look and be able to predict, climate anomalies? So can we look, a few years ahead? Can we look a decade ahead? What can we say about what's coming down the pike? So I would say it's still, it's not in its infancy, but it's maybe in its teenage years, the science of seasonal prediction, and that's part of why we developed the system at NCAR, is that we want to be able to use the model developed here in-house at the National Center for Atmospheric Research, be able to do predictions with it, and then provide that as a tool for research to the university community, so they can take our system and they can run it and they can do experiments and try to explore, what do we need to do to get even better at predicting the future. And so we want to, kind of entrain the entire university community in this effort.
I'm curious what the confidence is in this forecast for this 2.4.
We're looking at one system, and it's just our in-house system, and our confidence is based on the past performance. So, we don't only do forecast the future, we primarily do hindcasts, which is, we test it out and see if we could have predicted something that happened in the past. And so that's how we build up our confidence in the system. And in the news release, we included a plot that shows how our system has performed historically from 1970 all the way to present. And that's what gave us enough confidence to put out this news release. Is, we're able to predict all of the past super El Ninos very accurately when we initialize in August of that year. So we're initializing in August. We're trying to forecast what's going to happen in winter. And we nailed the 82, 83, 97, 98, and 2015, 2016 super El Ninos. So that, and also our system never predicted a super El Nino that didn't happen, right? So we don't have any false positives in our hindcast set. So that's why when we saw this, big anomaly, it gave us some confidence to say, this is a real possibility. And I don't have numbers to give you as far as our confidence. I know NOAA has an official El Nino report that, they'll give you some, 70% confidence of a strong El Nino or something like that. So ours is just based on the correlation score, which is, gives us, I would say, the correlation suggests that we're accurate, about 80% of the time.
What's the time period we're looking at here?
So we're predicting this as kind of being fully developed through the months of December, January, February. So we plan to do another forecast initialized in November, and that one we're going to be even more confident of, and we'll know then, if this is looking like it's going to happen. And plus, the other groups out there from around the world will have also submitted theirs, and I think we'll see kind of a convergence of these systems on the same answer, hopefully, as we approach winter.
Hey, thank you so much for watching. While you're here, check out some other videos you just may like.